Hey everybody, welcome back to IV Tutoring. My name is Caden. This is lesson 9 of the ACT prep course that we've been running over the past couple of weeks, right? The prep course being designed to actually improve students' ability to work on the ACT, practice, learn all of the strategies that you need to understand and all of the topics that you need to know going into the ACT test, right? Um, so lesson 9, welcome back to everybody. Lesson 9, if you watched the previous video, lesson 8 was on science, right? So we reviewed the science exam, right? We went over the different formats of the science passages, right? And as you know, the science test is optional. So instead of doing, two two videos based on science, I kind of shortened all of the information I wanted to put into one science video so that we could have a little bit more time reviewing some of the more important concepts that I think a lot of students are going to have a little bit of difficulty on the ACT that we haven't been able to get in the past. Okay, so that's what lesson 9 and 10, our final two lessons of the series, are going to be focused on the most, right? In today's video, I thought it was pertinent to go over some more math review. Basically, we're going to be reviewing more math questions because in our previous videos, we discussed kind of the what I thought were the most important and most missed types of questions and most missed content related topics, right? We went over trigonometry and its basic functions, law of sines, law of cosines, that kind of thing. We went over matrices and imaginary numbers, complex numbers, pre-calculus topics of that nature, right? That a lot of students might not have previously been exposed to or not have had the easiest time in the class, right? That they took. Okay, so we went over those things, but we also have to acknowledge that math is such a broad topic on the ACT and in general, right? There's so many different things to study in math and in mathematics. And there's so many different things that they can ask questions on, right? It's just not feasible for us to be able to get through every type of question they're going to see, right? So the biggest thing with improving your math score is just doing more and more questions and figuring out why you got the question wrong, right? Rather than trying to rather than trying to just take a class or watch videos telling you how to do certain concepts, right? The more important thing is just do more questions, right? Once you figure out why you're getting a question wrong, right, you can then go try to improve that specific area. But you have to first realize that this is the type of question I'm getting wrong, that kind of thing, right? So the purpose of today's video is just going to be doing more difficult math questions, right? Difficult questions that I assume that many of you are going to have trouble on if you saw them on the ACT, right? So in the previous video, we went through the first 32 questions of the practice test that I was planning on going through the whole thing of. Basically, what I'm saying is in lesson 5, previously in this series, I went through the full practice, or I went through the full first 32 questions. Okay, so we're going to finish that practice test up with the remaining 13 questions in this video, or at least in the first half of this video. And then at the end of this video, if time permits, I've prepared a couple of sufficiently hard practice questions that I've seen in the past and sufficiently interesting practice questions so that we can go over those. We have more material to cover. So the goal is you see a broad array of topics, aren't just repeating the same kind of thing, algebraic manipulation over and over again, right? So you're seeing all of these broad topics, and hopefully you're going to be able to nail down, okay, this is the concept I don't understand, this is the concept I do. Hopefully my explanation is enough to clarify those things, but of course topics are huge. My explanations aren't going to cover everything. So once you find the types of questions that you're getting wrong, right, definitely go check out some of the resources IV Tutoring provides so that you can go, read the prep book, the chapter on, whatever thing you need to review, right? So use this as a supplement, just like we've been talking about this entire thing. Use this course and this lesson specifically as a supplement for what you want to do and what work you need to get done, so that you can personalize this prep course to just exactly what you need, right? So yeah, let's without a lot more talking, right? We're about 5 minutes in. Might as well get straight into the actual math questions, right? We finished up question 32 last time. So the first question that we're going to do that we haven't done on this preparing for the ACT 2022 exam or 2025, 2026 exam that I've been doing all along is question 33. Okay, so let's get right into it. In a certain quadrilateral, two opposite angles each measure 3x plus 5. The other two opposite angles each measure x plus 3. What is the value of x? Okay, so we know it's a certain quadrilateral, right? The quadrilateral could be any shape, right? Right? As long as it has four sides, right? Like that's a quadrilateral. Well, I guess there's a little bit of a tail there. Erase that. But either way, that's a quadrilateral. So we know that it says in a certain quadrilateral, and we know nothing about, like it doesn't strictly say anything about the quadrilateral. However, what else do we know? We know that in the quadrilateral, there are two opposite angles, each that have the same measure, right? Their angle size is the exact same, right? So say we have 3x plus 5 looks like this, right? Say this is 3x plus 5. Then the other opposite angle also better be 3x plus 5, right? Doesn't say anything about the other two angles yet, but for that it's 3x plus 5, 3x plus 5. What we also know is that this is x plus 5 and this is x plus 5. Okay, it says that about the other set of two opposite angles. So what we have here is two pairs of opposite angles. Okay, and what this tells me is we no longer can have a quadrilateral that looks something like this, right? Why can't we have that? Well, we need some kind of symmetry, right? Because if we have 3x plus 5 on both sides, we need some kind of symmetry, at least angle symmetry down this center, right? And if the other sides are x plus 5, we also need angle symmetry down this direction. So really what we've shown is we kind of need some type of rhombus, some type of, diamond-ish shape. Diamond is not the exact right term, but if you're unfamiliar with the term rhombus, diamond might be a little bit more familiar. We need something where the opposite angles are equivalent in some capacity. We could also say a parallelogram would work, right? Where as long as this angle and this angle are the same, and this angle and this angle are the same, that's going to work, right? Okay, so we know we have some type of quadrilateral like this. Now it's asking us, what is the value of x? How do we go about doing this? Well, what else do we know about quadrilaterals? We know that, if these two sides are both 3x plus 5, and this side, or this angle is x plus 5, we've now shown that basically we must have some type of parallelogram or rhombus shape, right? And what that implies is, okay, these sides better be parallel. Okay, what does that imply? Well, let's actually look at this one. These sides better be parallel. Okay, so they're parallel. That means that these sides, right, like this side is I want to say it's a transverse line across these two parallel lines, right? And what do we know about alternating interior angles of parallel lines? Right. Well, that we know that this angle and this angle, we know they're equal, right? What we also know is that since the green ones are parallel, that means this direction going down this thing and this direction going up this thing are 180 degrees apart, right? If I'm going this way, I turn 180 degrees around, I'm going the exact opposite way in a parallel direction, right? Okay, so what that tells me is the angles that make this rotation possible, right, going, to make this a little bit more clear, going from here to here, that's angle 1, right? Then here to here, that's angle 2. Those two better be a 180 degree turn. So those two combined, added together, better be 180. That's the key here, okay? So those two angles, it's not what we want. 3x plus 5 and x plus 5. So 3x plus 5 and x plus 5 better be equal to 180. Okay, and now we have one variable, one equation, we can solve it. Okay, that was a little bit difficult for our way to kind of work through it and get to the exact equation that we needed, but once we get to the equation, it becomes very easy. All right, 3x plus x is 4x, 5 plus 5 is 10 equals 180. Subtract 180 or 10 from both sides, right? Oops, I realized I made a little bit of a mistake here. This should be x plus 3, and this becomes 8. Oops. With 8, and that's 180, and this becomes 10. I started to notice that none of our answer choices were going to be right. We have 4x equals 172, which then, if we divide by 4 on both sides, will give us 43. That's going to be answer choice C. Okay, let's continue. Question 34. The first 4 terms of a sequence are shown in the table. The sequence is defined by a1 equals 2 and an equals an minus 1 plus n minus 1 squared for n is greater than 2, greater than or equal to 2. What is the 6th term? A is 6 in this sequence. Okay, so it shows us the first 4 terms. Okay, now we're looking for a of 6. Okay, now the way we find a of 6, or the way we find the equation tells us to find a of 6 is, okay, well, to find a of n, you take a of n minus 1, right? So to find a of 6, right, we take a of 5, and then we do plus, well, what is n here? It's 6, right? 6 minus 1 squared. Okay, so we know a of 6 is equal to a of 5 plus 5 squared is 25. So we should be going up by 25 here. Okay, now what's a of 5? Well, we know a of 5 from the formula is just a of 4 plus 5 minus 1 squared, which will give us, well, we know a of 4 is 16, which gives us 16 plus, well, 5 minus 1 is 4 squared is 16, gives me 32. So a of 5 is now 32. Plugging that into this a of 5, you get 32 plus 25. That's going to give me 57. Okay, this is what's known as a recursive formula, right? We discussed this, I believe, before once, but it's what's known as a recursive formula. And essentially, if it gives you a formula where you need to use the previous number in the sequence to find the next one, right? Usually it's going to be pretty easy just to skip over just a couple. Basically, you're only going to be looking for like a of 6, and they give you the first 4, right? We only have to make 2 jumps, right? But if they ask you for a of like 400 or something, it's going to be very inefficient to use this recursive kind of structure, right? Because we're not going to be able to make 400 jumps in a meaningful time frame, right? So if we have a recursive formula and we want to find a really far away number, right, we're going to have to convert it into a direct formula, right? Basically, something that demonstrates, okay, let's give each of these numbers in the sequence an index. Basically, it's n value, 1, 2, 3, 4, whatever, right? We give each of them an index, and then after you've given them an index, based on that index, whatever index it is, you can find the answer just from the index. You don't need the previous number. Okay, so direct formulas are a little bit more useful in that capacity. But make sure you know the difference between those two. Okay, let's go to question 35. On the real number line, how many integers are between negative 65 over 6 and 75 over 2? So integers are pretty easy to count. Literally, integers are designed to count, right? Negative 1, negative 2, negative 3, or, 5, 6, 7, 8, 9, so on, okay? So it's basically just asking us how many integers are between, how many tick marks, if I was to draw this out, right, are between negative 65 over 6, okay, and all the way up to 75 over 2. 0 would be here, so, not drawn to scale, but pretty close, okay? I'll clarify that this is negative 65 over 6. Okay. So now, what do I do with this information? Well, I'm looking for integers. Well, we know 0's on there. We know 1's on there. We know 2's on there. So that's 3 so far. We also know negative 1's on there, negative 2. Okay. Well, when does it end? Well, where is negative 65 over 6? What is negative 65 over 6 in terms of integers? Negative 55 over 6 is equal to negative 10 and 5/6. Okay, negative 10 and 5/6. And that means negative 10 is going to be here, and negative 11 is going to be here. Okay, so if we're looking for the numbers between, the two values listed, right, negative 10 would work, but negative 11 wouldn't. Okay, so negative 10, negative 9, and so on, all the way up to, well, what number is right here? Let's figure that out. 75 over 2 can be written as 37 and 1/2, right? So we can go all the way up to 37, but once we go over to 38, we've crossed our line. Okay, so how do we find how many integers are between the two numbers? Well, we go from negative 10 to positive 37. Okay, how many numbers are between negative 10 and positive 37? Well, it's just 37 minus negative 10, which is going to give me 47. So there's 47 integers between negative 10 and 37. However, that's the number of whole integer jumps you make, right? That's the number of whole integer jumps you make, basically. That's what we do when we're subtracting. We're finding basically a length or how far we are distance-wise between two numbers, right? But we're including both the number negative 10 and 37 in our calculation, right? So we'd want to include negative 10 and negative 37. So we have to add that negative 10, that one extra piece that we didn't include in our subtraction at the beginning, right? And that gives us 48 total total integers between the two numbers. Okay. Let's go to question 36 now. During a particular experiment, two events, A and B, can each occur. Events A and B are mutually exclusive during this experiment. Which of the following probabilities is 0? Okay. What does it mean to be mutually exclusive? The term is pretty self-explanatory, to be honest. Once you hear it, it'll make sense. Okay. Mutually exclusive means if A happens, B can't. And if B happens, A can't. Okay, a good example of this would be like it is completely cloudy and it is completely sunny. Those two things are mutually exclusive events, right? In one environment, if I sit down right here and I go outside and I sit down and I look up, okay, the sky can be sunny or it can be cloudy, right? But it can't be there's no way it can be both fully sunny and fully cloudy, right? If those are the two, like A is fully sunny, B is fully cloudy, right? A and B are mutually exclusive. They cannot both happen at the same time. Okay, so they're mutually exclusive. Which of the following probabilities is 0? Okay, what does that tell me? Well, P of A is just the probability of A happening. It doesn't say anything about that. Mutually exclusive doesn't say anything about the individual actual probabilities of A and the individual probability of B. It just talks about what happens when you combine them, right? So say F and G are wrong, and then H, which of the following probabilities is 0? The probability that A or B occurs. That's not the case because, you know, there's a good chance it's either partially cloudy or partially sunny. I mean, fully cloudy or fully sunny if I go outside, right? There's a good chance that happens. There is a probability. It's not 0, okay? But J, probability of A and B occurring, right? What's the chances of that? Well, it's 0 because there's no chance it can be both sunny and fully cloudy at the same time, right? So J is going to be our correct answer. That's by definition of the term mutually exclusive. That's the way we get it. Okay. Okay, question 37. The polynomial function defined by p of x equals x cubed plus x squared minus 8x minus 12 has x minus 3 as one of its linear factors. What are all and only the zeros of p? Okay, so basically it's asking us what are the zeros of p. What zeros of p means is what are the zeros of the function p of x. Okay, and what does that mean? It means when or for what x values, basically for what x values does p of x equals 0. It's basically asking what values do I have to put into x so that p of x becomes 0. Okay. Well, we also know that x minus 3 is one of its linear factors. Okay, and a linear factor or a factor is basically anything that can be pulled out from a function, any set or term that can be pulled out from a function, right? And when we say pulled out, we mean that its value, that term's value, equals 0. Okay, so it doesn't actually include anything to the function, right? P of x equals this thing times something else, okay? And its value is equal to 0 when p of x equals 0. Okay, so x minus 3 equals 0 when p of x equals 0. And that means whatever x value solves this equation is a 0 of p. Okay, so what x value solves this equation? Well, it's pretty clear to see that x equals 3 is going to be a 0 of p. That means that x equals 3 is going to be one of the zeros. So 3 is one of our options. So now we're between -2 and 2. Okay, and there's a couple of ways to do this. If we didn't have any answer choices, right, the proper way to do this would be to take x cubed plus x squared minus 8x minus 12, okay, and take out the linear factor we know of, okay, because we can't really, it's tough for us to solve for x from here when we set it equal to 0, right? But if we were to take out a factor of x minus 3 via long division, right, we could fairly simply, we'd be left with an x squared term, a quadratic, right? And we can solve quadratics with quadratic formula, right? And then when you solve it, when you set it equal to 0 and solve it, that'll give you one of the factors. The other alternative option is to basically set p of x equal to 0, say something like this, right here. Say x cubed plus x squared minus 8x minus 12 equals 0, and then plug in positive 2 and negative 2 and see which of them actually does give me 0 and which gives me something that's non-zero. Okay, so we're going to do that. Let's plug in 2. 2 cubed is 8 plus 2 squared, which is 4, minus 8 times 2, which is minus 16, minus 12. So 8 plus 4 is 12, minus 16 minus 12. That gives me negative 16. So it's not going to be 2 and 3. Right, now let's make sure that it's negative 2 does work. Right, let's make sure negative 2 works. Negative 2 cubed is going to be negative 8. Plus negative 2 squared is going to be negative 8 plus 4. Minus 8 times negative 2 is going to be negative 8 plus 4 plus 16. And then minus 12, that gives me negative 4 plus 4 equals 0. That's correct. Okay, so answer choice C is actually going to be our best option here. Let's continue. Question 38. Jonathan rode his bike every day for 18 days. The table shows the distances, each of the distances he rode. The table also shows the number of days he rode each of those distances. Okay, what is the median daily distance in miles that Jonathan rode his bike for the 18 days? Okay, how do we figure this out? We're looking for median. Okay, what we know is he ran 2 days at 1 mile, so he ran 1, then 1. Okay, and then he ran 4 days at 3 miles, or like 4 days for 3 miles. 3, 3, 3, 3. Okay, and then he ran 3 days at 4 miles. 4, 4, 4. Okay, and so on. So if we were to list these sequentially, we would have a list of going from 1 to 7, right? 1, 1, 3, 3, 3, 3, 4, 4, 5, 5, 5, 5, 5, 5, or 5, 5, 5, 5, 5, 5, and then 7, 7, 7, based on the data that we have here. Okay, and basically with that information, if we're looking for a median, median is the middle number in a sequence or a sequence of numbers, right? It's the middle number, right? And middle number of 18, what is in the middle of 18, right? Well, the middle of 18 is the 9.5th number. Basically, the middle of 18 numbers lined up in a row, there's 9 in the first half, 9 in the second half, right? So between the 9th and 10th digit, right, in the sequence, that's where our median lies, okay? So we just have to figure out what our 9th and 10th digits are. 1, 2, 3, 4, 5, 6, 7, 8, 9. So our 9th digit is 4, right? And then that's the last one of the 4s, and then we have a 5. So we're left with the 5 is our 10th digit. So what is basically we take the average or the middle value of these two median terms. What's the average of 4 and 5? Well, 4 plus 5 divided by 2 is 4.5. Right? So that's going to give me the median for our set of data. Okay? Okay, question 39. A tourism organization randomly selected 100 tourists finishing their summer visit to Spain. The organization asked them how many cities they had toured in the country. The table showed the results. Based on this data, for the population of tourists that visited Spain during the summer, what is the best estimate of the mean number of cities toured? Okay, so we're looking for best estimate of the mean number of cities toured. Okay, So this is 100 total tourists, right? So there's 100 people, right? The way we find the average or the mean number of cities toured per person, right? Um, the way that you would go about solving this is to find the total number of cities that were toured in general, right? And then you divide it by the total number of people. Okay, so we know that 10 people toured one city, so there's 10 cities toured. Okay, so there's 10 individual occurrences of a person touring a city. Okay, and then we know 40 people toured two cities. Okay, so that's another 2 times 40 or 80 cities that are toured, or city touring occurrences. Okay, and then we also have 50 people that toured three cities. So we also have 3 times 50, which gives me 150 total city touring occurrences in that category. Okay, and that's going to leave us with 240 total cities toured, total city touring occurrences. TCTO. Okay, and that's an interesting acronym, but either way. Okay, and then that's going to, we now know that there's 100 tourists, right? We also know there's 100 tourists, so number of cities toured per person, right, will give us a specific value of 2.4. And 2.4 is going to be our option, our best answer, okay? On to the final couple of pages here, for this test, I should say. Okay. Question 40. Given the equation, the fourth root of x equals y, where y is a real number, what must be true of x? Okay, so we know, what do we know from here? We know that we're taking the fourth root of some value x. We're figuring out what specific or specifications need to be true of x. And we're also looking at, we know y is real. Okay, what happens when you cube or take the fourth root of something? Okay, well, this is a little bit of intuition that you should have developed over time, right? Or should be developing over time, I should say. But the fourth root of something, it's an even root, right? And what that means is if you take like the fourth root of a positive number, right? Or so let's do it with a little bit simpler thing. Let's say we take a square root, another even root, right? 2 is an even number, 4 is an even number. We call them even roots. Okay. What's the square root of, I don't know, let's say 9. Okay. That's going to be plus or minus 3. So we have real values here. We have real answers. What's the square root of negative 9? Well, taking the square root of a negative number, you should remember from our previous discussion, gives you a complex answer, or gives you a imaginary answer. So 3i would be our correct answer, right? Okay, so we see that we moved out of the plane of real numbers. So if we were taking a square root, we realized we can't have a negative number inside to get a real value. Okay. Now what happens with the cube root? Okay, what's the cube root of, say, 8? What's the cube root of 8? Well, it's plus or minus 2. Or no, I should say it's positive 2. Oops. It's positive 2. Okay, well now what's the cube root of negative 8? Cube root of negative 8. Now you might think, oh, negative 2. Yeah, that's right, negative 2, because negative 2 times negative 2, right, is positive 4. And then times negative 2 again is going to give you negative 8. So this is negative 2. Okay, so we now see that no matter if we put a negative number or a positive number inside this odd root, this root of a cube, right, or this cube root, right, we have no imaginary solutions. We have real solutions in both cases. Okay, so that's the distinction, right? For this is even roots. This is odd roots. And what we're left with is a clear distinction such that every even root, if you want to get a real solution, if you want to get a real outcome, you better be putting a positive number, or at least a non-negative number, inside of the root. Okay, so since y is a real number, we better be putting a non-negative number inside the real root. So x better be non-negative. That means x better be j, a non-negative real number. Okay. So this one, you could have gone down the 4 options and kind of tested your way through if that would have worked with you if you hadn't developed this intuition. But hopefully, now that we went through those even versus odd roots, you develop an intuition for why some roots give you imaginary numbers and some roots do not. Okay. Let's go to question 41. Given that 1 is less than or equal to m, which is less than or equal to 4, 4 is less than or equal to n, which is less than or equal to 6, and 8 is less than or equal to p, which is less than or equal to 10, what is the greatest possible value for m over n times 1 over p? Okay, so we're looking for the greatest possible value. Now, given that you have the greatest possible value, right, you're trying to maximize each variable, right? So you have m over, or I should say, you're trying to maximize each variable's contribution to the total value. So we're looking to maximize this thing, okay? If we want to maximize, if we want to make m the thing that maximizes this, right? Does a bigger m make our value bigger or smaller? It makes it bigger, right? Because m is in the numerator here. So as we increase m, right? If m is 100 instead of 50, right? Our total value just went up by a factor of 2, right? Going from 100 to from 50 to 100, right? Okay, so we have a discussion here to talk about, okay, which value or which of these numbers maximizes m? Well, it's pretty clear, right? If we want to make m bigger, right, 4 is the highest possible value we can put in. So we say m equals 4. That's our maximum value. Okay. How about n? If we have n, do we want to minimize or maximize n in order to maximize our total expression here? We actually want to minimize it because the smaller the value of n, right? If we're dividing by n, we want to divide by a smaller number, right? If we divide by a bigger number, our expression value is going to get smaller and smaller. But if we divide by a smaller number, our expression value is going to get bigger and bigger, right? So we want our n to be small. Okay, so what's the smallest we can make n? Well, we can make n 4. That's the smallest we can make n. Okay, what about p? What do we want with p? Well, p is also in the denominator, so p acts just like n, right? The bigger we make p, the smaller we get as an expression value. So we want p to be minimized as well. Okay, so p is going to be 8. What this leaves us with is 4 over 4 times 1 over 8, which is just 1 times 1 over 8, which is 1 over 8. That's going to be answer choice D. Okay. Question 42. Which of the following data sets has the largest standard deviation? Okay. So we need to be able to figure out, what does standard deviation mean? We don't need to be able to calculate it for the ACT. But for this question, what is a standard deviation? Okay. A standard deviation is essentially a measurement of the typical distance away from the median value in some type of data set or range. Okay. What I mean by that is, let's say we're getting test scores. We're getting test scores back, and the average was a 70, or the median was a 75, right? And everybody in the class got within a 70 and an 80, right? Nobody really did super well. Nobody got 100, right? But nobody also failed, right? So everybody got between a 70 and 80. That would be a small standard deviation, right? Because the standard difference between the center, 75, and the whatever value you got on either side, lower or higher than 75, that difference is very small, right? Most people got very close to 75, okay? But let's say that the class was much more spread out, right? And there's a large group of people who got, 85s, 90s, 95s, 100s, right? And a large group of people who got 55, 60, 40, that kind of thing. Standard deviation, the data set is being pulled apart. Its standard deviation, the standard distance away from the center, is much larger now. Okay, so we have to figure out which of these data sets has kind of this largest spread. Okay, what I see immediately is that the median here between 0, 0, 10, 10 is 5. Okay, and it looks like we're basically as far as we can get away from 5 without leaving, without going negative and without really going above into double digits, right? We're still at 10, but above 10, right? That's kind of the limit. Okay, so this is a super high standard deviation, one of the maxes you can do in this scenario. Okay, so 10 is going to have a really high standard deviation. So I like 10 as an answer. G is going to be a little bit smaller, right? Because these are the exact same, so comparing them makes it the exact, you don't get any change in the standard deviation. The median is still 5, the average of 1 and 9 is 5, just like the average of 0 and 10 is 5. But 1 is a little bit closer to 5 than 0 is. And 9 is a little bit closer to 5 than 10 is, right? Just by a little bit, but it is. And that reduces our standard deviation because things are a little bit closer together, right, on average. Okay? So I like F better than G. And then that's going to be, those are the only two that are really competing because J, everything is the median, right? That's as compact as you can get it. So that's the smallest standard deviation of 0, right? And then H is, decently spread out, but nothing crazy like 0 to 10, right? So H is going to be wrong as well. F is going to be our best option. Okay, next one, 43. Michael has a cylindrical fish tank shown that has an inside diameter of 18 inches. When he put colored fish in his fish tank, the water level of the tank rose 2 inches. What is the volume of the gravel in cubic inches? Okay, so we're looking for the volume of the gravel. Okay, we know that the diameter of this tank is 18 inches. It shows us that. Okay, and we know that when he puts gravel in, the water rises, right? The water level rises by 2 inches. What does that tell me? So previously, in the tank before you put the water in, whoops, try to draw this nicely for you. See how well I can do, but no promises because I'm not an artist, but that didn't turn out too bad, You can at least tell it's a tank. That's all that matters, okay? So in the previous scenario, here is our water level. Okay, so here's our water level with our fish, and the gravel hasn't been put in. And then when we put the gravel in, there's water down here, right? There's water in this section, right? Specifically in these bottom 2 inches, right? That water, when the gravel comes in, that water can no longer be there, right? It must disperse, right? And the new water level goes up. It starts at 2 inches higher. Basically, the bottom is being raised up by 2 inches, okay? And there's nothing but gravel down here. Gravel, I should say, okay? So that's gravel, okay? And now the water has been raised up by 2 inches because the gravel's full volume goes in by 2 inches. Okay, hopefully that makes sense. So that means we have 2 inches here. We have 18 inches in diameter, and we're looking for the volume of gravel, right? Well, what is this volume of gravel shaped as? Well, it's just a disk. It's a cylinder with a small height. What's the volume of a cylinder? Well, volume of a cylinder is the area of the base times the height, which is equal to pi r squared times the height. And pi times r, what is our r? A radius of this circle. Well, radius of a diameter 18 is just 9. 9 squared times our height of 2 inches. So that's 81 pi times 2, or 162 pi. That's going to be answer choice C. Okay. Yes, that's good. Okay. Let's do next question 44. The table gives values of f of x, g of x, and h of x for all positive integers x is less than 5. Given that h of f of g of a is equal to 1, where a is a positive integer less than or equal to 5, what is the value of a? Okay, so we're looking for a value of a. We know h of f of g of a is equal to 1. That means h of something better be equal to 1. Okay, h of something better be equal to 1. Okay, well, what does that tell me? Why do I know this? Why, first of all? Because if h of f of g of a is equal to 1, then if we can just say f of g of a is some set value, some question mark, some value, right? It's something. We're taking h of that value and it produces 1. Okay? What this tells me is, well, what values do h of x, work for? Well, let's see. Here, h of x, right, produces a value of 1 when x equals 2. So this question mark is going to be equal to 2. So this question mark is 2. So we have f of g of a is equal to 2. Okay, down we do the same exact strategy. F of some value is equal to 2. What value of f produces 2? What value of f produces a 2? Oh, well, when x equals 1, or when our question mark equals 1. So f of 1 equals 2, which means g of a equals 1. When does g of a equal 1? Well, for what value of a does g of x equal 1? Or what value of x does g of x equal 1? Well, Here, that's g of x equals 1. What was the value of x? 5. So a is going to be 5. Okay, so we did the same exact strategy over and over again, right? Just nesting inside, right? Making everything on the inside a variable, looking at the chart, figuring out what the variable is, then doing the same thing with the next set of nested, parentheses, okay? Nested functions. Okay, so this is question 44. Now we're on to question 45, the final one of this test, okay? So these are, the hardest questions on the ACT test, okay? And as you see, these might be a little bit difficult, might be confusing, but there's not really anything high level, no super high level math going on, right? No advanced pre-calculus, no calculus, anything like that. No super advanced statistics. If you understand, at an intuitive level what's going on, you're going to make these questions way easier, okay? So make sure you're reading the questions when you're doing them, so you don't make, silly mistakes like this, okay? Okay, each time coin C is tossed, it lands face up or face down. The probability of landing face up is 3 times the probability of landing face down. In a certain game, the player wins $1 if coin C lands face up, and the player wins $2 when coin C lands face down. To the nearest cent, what is the expected value of each coin toss of coin C in this game? What is expected value? Okay, an expected value at face value is what the total amount of money you expect to earn, or the total amount of value you expect to get out of a singular event, a singular coin toss in this case. Okay, now we don't do it by just guessing which one we're going to get. We mathematically use the weight distribution of all of the options, right? The chance that all of the options happen, and then the payout or the value that you're going to get if any single one of these options does happen. Okay, so what's the probability, basically, of landing face up? Well, or what are the percent chances we land face up? Well, it's 3 times the land face down. Okay, so it's 3 times the land face down option. Okay, so if we wrote this visually, right, of every coin flip we were to do, if we did infinite coin flips, right, 3/4 of them, right, this section would be face up, and this section would be face down. So the probability, the weight distribution, is that 75% of the time, or 0.75 of the total possible outcomes, right, are going to give you a face-up solution. And in terms of value, that means 75% of the time, you're going to win $1, right? Now, the other 25% of the time, it's going to land face down, and you're going to win $2. Okay, so if it lands face up, you win. Well, the odds of you winning money on the face up is, well, the expected value of face up money that you're going to get is 75 cents, right, or $0.75, right? And the expected value for the face down section is going to be $0.5, right, for any given toss. You add these two together because you're adding for a total probability, right? You're looking for on any given coin toss, not given the outcome yet, so you could get either outcome, right? What's the expected total payout? Well, it's going to be $1.25. Okay, so the way we find expected value is you basically find the weights, right? The percentage chance or the decimal chance that something happens, and then you multiply it by the payout or the value of that occurs when that thing happens, right? Okay, there it is. So yeah, the first one I want to go over here is in the September 2024 exam, question 31 and 32. These are 2 interesting questions that cover topics that we may have discussed a little bit in the past, but have a different approach on them. So question 31. Tables of values for the 2 functions f and g are shown below. What is the value of g of f of 5? Okay, so this is working the other direction from the previous question we did with nested values, right? So here we're actually just finding g of f of 5. So what are we going to do? We're going to work from the inside out. On the other one, we worked kind of from the outside in, didn't care about the inside until we got to it, right? Now we're working inside out. So when we want to find the total value of a nested function, rather than finding the input to a nested function to produce a value, right? We want to work the other way, okay? So you just plug in, well, let's look at the inside. What is f of 5? Well, f of 5 is, f of 5, basically f of, when x is 5, f of 5 is going to produce 4. So now we have g of 4. G of 4, well, when is 4 our input? That's going to produce us -5 as an output. That's going to be answer choice C. Right, so these questions might not be super difficult, right? But they're going to be discussing concepts that are very important to make sure you have an idea about, okay? Here, question 32. We mentioned something about this earlier. This might help clarify that very early parallelogram question or quadrilateral question, okay? Question 32. In the figure below, line L is parallel to line M, and line N intersects the plane, parallel lines. What is the value of x? Basically, doing the same thing we did last time, but what we notice is, okay, remember, if we have a line that's going this direction, right, we can also say it's going this direction, doesn't matter, it's kind of arbitrary, okay, and we want to flip our direction to go this direction, right? If we were to follow along this kind of curved path that takes us there, it's kind of taking you down and then going around and then going up this way. And that's a 180-degree change, right? It's 180 degrees of change. We're going directly in one direction and then completely in the opposite direction afterwards, right? So that 180-degree change can be evaluated by looking just at the individual angles, right? This angle plus this angle better be equal to that whole 180-degree change. Other than that, we're staying straight, right? We change directions once, and then we change directions twice, and then by this point we've changed completely, okay? So 3x plus 5 plus x plus 15 equals 180, and we're going to be left with 4x plus 20 equals 180, minus 20 will give you 160, divided by 4 is going to give you 40. Answer choice J, okay? Let's go to question 33. Which of the following expressions is equal to 2 root 7 plus 1 times, okay. All right, let's go to the next question that I have prepared. The next question is, let's see, it's a little bit further down the road, but question 43. I think this one's interesting because we discussed the law of sines, right? So we might have discussed it earlier. I might have mentioned it briefly, but not actually gone over it. Let's go over the law of sines. Okay, but first let's read the question. The area of any triangle is given by 1/2 area or A times B sine of C, where A and B are the lengths of any two sides, and C is the interior angle formed by those two sides. Which of the following is closest to the area in square feet of a triangle with side lengths of 6.2 feet and 10.0 feet and 14.0 feet, with angle measures 23, 39, and 118? Okay, how do we do this? We're looking for the area. We know that the side lengths are 6.2, 10, and 14. Okay, so we have 6.2, 10, and 14. Okay, so we know the longest side better be opposite the largest angle. That's the idea here. The longest side is going to be opposite the largest angle. Okay, so our largest angle is 118. Okay, and the longest side is going to be 14. Okay, so that's our angle. And then the smallest angle is going to be opposite the smallest side. So this is 23, meaning this is 6.2. This is 10. This is the medium angle, medium side, 39. Okay, so now we have constructed our triangle, right? We always want to draw a picture of what's going on. It's the most important part of any question that doesn't have a picture already associated with it. Okay, so you draw a picture, and it's asking us to evaluate its area. So we're literally just going to pick which values we want A, B, and C to be, right? And then, figure out our answer, okay? So 1/2, let's pick A and B. Let's say A and B is this value, right? That is going to be 6.2 and times 10. And then what is C based on this definition here? Well, C is the interior angle formed by those two sides, right? The interior angle formed by 6.2 and 10. In this case, that's right here, that's angle 118. So what we have to do is we have to take sine of that angle, C, 118. Okay, and we know sine of 118, it gives us to us is 0.88, okay, which is going to produce us 62 divided by 2 times 0.88, which is going to give us 31 times 0.88, which is going to produce about 27. Okay, about 27. And that's going to be our answer choice B. Okay, this one did not actually cover the law of sines, right? It looked like it was going to be a little bit similar, But it's still a very important practice on being able to interpret this type of question right here. Okay, moving into that was the last question I had on that test, right? Moving into the next test of things that I want to cover, interesting questions I saw. Let's go to question 53. For all real numbers x and y, the two operations, star and diamond, are defined below. X star y is equal to x times y plus y, and x diamond y is x plus x times y. Okay? For all real numbers a and b, what is a diamond b star b? Okay, the way we do this is we literally just evaluate using PEMDAS, just like we normally would. Okay, so PEMDAS says we do the things in the parentheses first. So we're going to do a diamond b. Okay, what is a diamond b? Well, a diamond b, whoops, it's not a diamond, there we go. B is going to be the same thing as x diamond y, except with a and b replacing x and y. So it's going to give us a plus a times b. So that's this value. That's this thing. And then it says take that value and do star b. Okay, so this thing, right, star b, what does star have us do? It takes x star y, and it takes x times y plus y. So a plus a times b, that's x. That's our equivalent x right here. And then we multiply that by our equivalent y, which is b. Okay. And then we just add y, so plus b. And that's going to be our final answer when we simplify it out. Okay, so we get ab plus ab squared plus b. And which of our answer choices shows this one as our proper option? Well, it's going to be answer choice D. Okay. Answer choice D. Okay. Next one I want to go over is question 52. The tablecloth shown below is white except for a pattern formed by 4 red rectangular strips, each 2 inches wide and 36 inches long, arranged as shown. If all angles are formed by the strips are right angles, how many square inches of tablecloth are red? Basically, it's asking what is the area of this, weird kind of shape, hashtag-ish shape, right, covered by these red stripes. The way we figure it out is we literally just, do it piece by piece, okay? We know that there are 4 red strips here. We have this strip, we have this strip, right? We have this strip, and we have this one. Okay, so 4 kind of primary strips, okay? And each individual strip has what area? Well, it has area, dimensions 2 by 36, or whatever. Okay, so let's find the area of this. The area of a rectangle is length times width. So we take 2 times 36, and that gives us 72. Okay, so our area is 72 of each one, and there's 4 of them. What that tells me is, okay, well, we have to multiply this number by 4 to get our area. Okay, that's going to give us 288. Okay, so that's our area of 4 red strips. However, there's some overlap here, right? In this period, we overlapped one of, like, say this one's on top, or let's say that one's on bottom and this one's on top, right? The one on top is covering up the one on bottom's area. So that part of the tablecloth, that part of this red, that part of the undercover one is actually covered up and shouldn't be included. And now how big is this red square? Well, if we remember correctly, this is a 2-inch by 36-inch piece. This is also a 2-inch, right? Meaning this red square is going to have dimensions 2 by 2. Okay? So this red square is going to have area of, I should say, 4, right? So the red square is area 4. So we have to take away 4 for that one. We also have to do this for the overlap that we have here, and the overlap we have here, and the overlap we have here. Because in each case, one of the red strips is getting covered up. We counted it as exposed area, but it's not exposed. It's hidden, right? So we have to subtract 4. We have to do it 4 times. Okay, so we're actually going to be subtracting 16. We're left with 288 minus 16. What that's going to do is it's going to give me 272. Correct answer choice F. Okay? The last question I think I'm going to be able to do in today's video is question 49 from this test right here. Okay, this is the April 2023 test for anybody wondering. Okay, 49 is counting repetition. How many prime factors appear in any prime factorization of the integer 63 to the 5th? Okay, what's going on here? What are they talking about? Prime factorization, we talk about this in video 4 ad nauseum. We talk about it at length. If you don't know what prime factorization is, go back and watch that video. If that video isn't super helpful, right, go try to study it in the Ivy Tutoring ACT resources. Okay. But anyway, make sure you understand what prime factorization is because we're going to use it in this question and you're going to use it on your ACT. Okay. So let's say we have a number. Its prime factors are basically the numbers that make it up. Okay. So what are the prime factors of 36 or 63? Well, 63 is 3 times 21. 21 is 3 times 7. Okay, so the prime factors are a 3, a 3, and a 7. So 63 prime factorizes 3 times 3 times 7. Okay, what is 6? We're looking for the integer 63 to the 5th, right? 63 to the 5th power. Okay, what is 63 to the 5th power, right? Well, 63 to the 5th power, we don't need to know what that number is. We know 63 to the 5th power is 3 times 3 times 7 to the 5th. That's also just the same thing as 3 to the 5th times 3 to the 5th times 7 to the 5th. Okay? And what can we do with that information? Well, 3 to the 5th is just 3 times 3 times 3 times 3 times 3. And then another 3 to the 5th, 3 times 3 times 3 times 3 times 3 times another 7, right? 5 sevens. Okay? And what we're left with is we see there's 15 prime factors, right? 10 threes and 5 sevens. Okay? So that's going to be kind of how we approach a question like this. This is kind of a rare question. Definitely wanted to demonstrate it, but I also wanted to use it as a reminder for how to do prime factorization when it can come into handy, right? Prime factor is the prime factorization of any integer, right, is exactly equivalent to that integer by definition, right? Keep that in your mind, right? You can use that to your advantage on a question like this, right? Sorry, I don't know whether you can actually see the bottom corner there, but that's going to be our right answer. Okay. So yeah, that's going to be it for today's video, right? We went through a decent number of difficult math questions. Proud of that, right? Hopefully, you use this time to prepare yourself for the upcoming ACT math sections, right? And thank you for coming to lesson 9, right? Lesson 10, our final review video, which you'll see next time from me, is going to be kind of a send-off in the English and reading sections. Basically, we're going to be reviewing strategies that we've talked about, tips on what I think you should do the day before the ACT in general, right? And doing a little bit more review of English and reading for those of you that wanted to do a little bit more review that we haven't had the chance to do so yet. Okay. Biggest advice for you: continue doing practice. Right. Always do a ton of practice questions. It's the most important part. Okay. So keep doing practice. Good luck with your prep, and I'll see you in lesson 10. Bye now.